Today's our first lesson on polygons. Okay, so we're just going to be going over the basics. Polygons have angles, they have sides. We're going to go over different types of polygons, starting with the definition. A polygon is a plane figure that's formed by 3 or more line segments. Okay, first of all, plane figure. Remember, a plane is a flat surface, so a polygon has to be in a single flat surface. And then it has at least 3 sides, could have more than 3 sides. A polygon cannot have any curves, gaps, extra pieces, or crossing sides. Okay, so the one example here is polygon ABCDE. It has 5 sides and 5 angles. Okay, our first definition in geometry, consecutive means next to. Okay, so if we're talking about consecutive sides, those are sides next to each other. Like side AB and side BC would be consecutive sides. AB, BC. Consecutive angles would be angles that are next to each other. So angle A and angle B are consecutive, and then consecutive vertices would be like the corners or the points that are next to each other. So say D and C, for example. Okay. A diagonal is a segment that connects 2 non-consecutive vertices. Okay, remember, consecutive means next to each other, non-consecutive means not next to each other. Okay, so for example, A all the way to D, that would be a diagonal because that connects 2 vertices that aren't next to each other. Maybe A all the way to C would be another one. There's several on here to draw. There's D to B. Let's see, there is E to B. And then I'll go ahead and draw the last one here. EC. Okay, so there's a lot of diagonals in the picture. The more sides you have, the more vertices you have, and then the more diagonals you have as well. Okay, next definitions. Convex versus concave. When I think about convex and concave, I always think about a spoon. The side that's bowed out, that's the convex side. The side that's curved in, that you would be like scooping and eating with, that's the concave side. Okay, with respect to polygons, there's 2 types. Convex means all the diagonals are inside the polygon. Basically, if all the diagonals are inside the polygon, like on this example, that means all the corners are pointing out. Okay, the concave example, at least one diagonal is going to be outside the polygon. So if you connect 9 consecutive vertices, you end up with this diagonal outside the polygon. Okay, what that means is that one of the corners is pointing in, and that's concave. Okay, so whenever you see a polygon where all the sides point out, all the corners point out, that's convex. Whenever you have one where maybe even most of the corners point out, but one of those corners points in, that's going to be concave. Okay, so what we've got to do for the next section is figure out if it's a polygon, and then is it convex or concave. Okay, so for the first one, it has 1, 2, 3, 4, 5 sides, and all the corners point out. So yes, it's a polygon, and it is convex. The second one has this part where these 2 edges cross over each other. That's not allowed with a polygon, so this one is in fact not a polygon. C, not a polygon again. It has this curved side. Polygons can't have curves. D, this gap. Polygons don't have gaps. All the straight edges have to meet up, so no again. And then the last one here, this one has all the edges that meet up. So that is a polygon. And then as far as concave or convex, you can draw a diagonal outside the polygon here. There's a corner that points in, so it is concave. Okay. The next important thing to know about polygons is all the different types of names of polygons. Okay, so as far as classifying polygons, there's official names depending on how many sides it has. So, for example, if a polygon has 3 sides, we call that a triangle. Okay, if it has 4 sides, you guys know all kinds of 4-sided polygons, like square, rectangle, but there's like a more general term. In general, if a polygon has 4 sides, we call it a quadrilateral. Five sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. Okay, and then after you get bigger than 10, there's not as many specific names for polygons. For most types of polygons that have more than 10 sides, the best way to label them is just use the number and then write -gon. So for an 11-sided shape, go ahead and write 11-gon. Okay. For a 12-sided shape, it does have a specific name, dodecagon. And for an n-sided shape, n just stands for the number of sides. So if it's 15, 35, 190, write that number and then -gon. Okay, now we're going to go specifically on to quadrilaterals. There's a rule here. This is something you're going to have to memorize for the rest of the year. Okay, in a quadrilateral, all the angles will add up to 360 degrees. Okay, so remember, with a triangle, all the angles added up to 180. Quadrilateral of 4 sides, they all add up to 360. Okay, so that rule is going to help us find the unknown angle for each of these problems. Okay, so for the first one, this is a quadrilateral. One of the angles is 60, one is 102, one is 67, and one is x. So I'm just going to write myself an equation. 60 plus 102 plus 67 plus whatever x is. All those 4 angles have to add up to 360 degrees. So once I've got my equation set up, all I've got to do is solve. That means first combining all the like terms, which are 60, 102, and 67. 60 plus 102 plus 67, you might need a calculator. I believe that adds up to 229. So I have 229 plus x equals 360. And then I've just got to subtract that 229 from both sides. I end up with x equals 131. Okay, so the unknown angle in that quadrilateral is 131 degrees. Okay, the next example is really similar in that the quadrilateral, I know the 4 angles, so I've got to set up an equation. Those 4 angles must add up to 360. So 75 plus 83 plus 112 plus 6x equals 360. Okay, and then from there, combine like terms. 75 plus 83 plus 112, that all adds up to 270, plus 6x equals 360. And then I can subtract that 270 from both sides, and end up with 6x equals 90. And all I've got to do is divide by 6 on both sides, so x equals 15. Okay, so for the second quadrilateral, x equals 15. Okay, next bit of definitions. These ones are going to sound really familiar. Okay, an equilateral polygon has all congruent. Well, equilateral was a word you learned to do with triangles, so equilateral with respect to polygons is the exact same thing. Equilateral means all the sides are congruent. Okay, an equiangular polygon has all congruent, well, equiangular with respect to triangles meant congruent angles. Same thing with polygons. Okay, a regular polygon has all congruent sides and angles. So actually the word regular means any polygon is both equilateral and equiangular. Okay, go ahead, check down to the next problem. Tell whether each polygon is equilateral, equiangular, regular, or neither. Okay, so for each example, we've got to see which of those definitions applies. Okay, for the first example, check out the sides. This side and this side, they have different marks, so that's not equilateral. The sides are different lengths. But for the angles, they all have the right angle symbol, so this one is equiangular. Okay, the next one. If you look at the sides, they all have that single dash, so all the sides are the same, so that's equilateral. But as far as the angles go, this one has a double arc, this one has a single arc, so those are different measures, so it's not equiangular. Next example, for the sides, they all have a single dash, so that's equilateral. And the angles are all the right angle marks, so equiangular as well. Okay, and then if the angles are the same, the sides are all the same, that's a regular polygon. Okay, so the term regular actually includes both equilateral and equiangular. Okay, so those are the basics of polygons, and we'll go over more in class tomorrow.